Hi there, welcome back. So we just defined what is a continuity equation and we derived all the equations that can be associated with a continuity equation. Now let us do an example for a continuity equation. We have fluid entering and our fluid is said to be oil. It's entering through a pipeline and our pipeline converges and separates into fork and discharges at point C and D. So we have fluid entering and it passes point A, point B, point C and point D. We are given diameter for A, B, C, D. We also give the velocity for A and velocity for D. What is the discharge at point C and D? Notice that we are given our diameter in terms of 450 millimeters. To convert from millimeters to meters, all you have to do is multiply by 10 to the power of minus 3 and you will be able to convert from millimeter to meters, which is 0.45. We can say flow rate at point A is equal to flow rate at point B. Volumetric flow rate is in the units meter cubed per second. We know that volumetric flow rate at A can be written also as velocity at A and area at A, which is equals to velocity at B and area at B. We can also say that volumetric flow rate at A can be equated to volumetric flow rate at C plus volumetric flow rate at D. Can also be further expanded to velocity at A, area A, which is equals to velocity at C, area C, and velocity at D, area D. The discharge at A can be expressed as, and we know that area can be defined as, we are given both the velocity and the area. Hence, our answer can be calculated to be the discharge at C can be written as discharge at D written as, since we are given both the velocity at D and the diameter at D, we can substitute. Therefore, the discharge at D can be calculated as 0.143 meter cubed per second. If we make QC, which is the volumetric flow rate at C, subject of the formula, now that we know the volumetric flow rate at C, if we equate and go back to this equation, sorry about this here, we had 0.15 squared, which should give us 0.18. .94 meters per second. We calculated the volumetric flow rate at A, C, and D, and we also now know the velocity at point C. I hope that makes sense. Thank you so much for watching.